Hello viewers, welcome back to my YouTube channel. If you are joining us for the first time or this is the first time you are watching this channel, thank you for stopping by. Previously, we looked at capacitors, of which we said that capacitor is a device for storing electric charges or for storing electricity. We also said that this capacitor is made up of two parallel metal plates of equal charges, which is separated by an insulator. Okay, then we also discuss how we can arrange this capacitor series and parallel connection. So if you don't know how to calculate the effective capacitance when it is connected in series and in parallel, you can check my previous video when I did the calculation on that. Let's see how a capacitor can store electric energy. So energy stored in a capacitor. Energy stored in a capacitor is equivalent to the work done in charging the capacitor. It means that a capacitor is charged so that it can store electrical energy. Okay, so we can also say that energy stored is equal to work done. So you have this following formula to use to solve or calculate energy stored or work done by a capacitor. E is equals to half CV square or half QV or half Q square over C. Now, depending on the parameters given, if you have the parameters that involve the capacitance and potential difference, you are going to use this one. If you have the parameters that involves the charge and the PD, you are going to use this one. You also have a parameter that involves the charge and the capacitance, you are going to use this one. Okay, now what is my C? C is capacitance of a capacitor, V is potential difference, and Q is charge. So we are going to look at how we can use this formula to solve for energy stored in a capacitor. Stay tuned. Let's solve this example on the board. Calculate the energy stored in a 20 microfarad capacitor if the potential difference between the plates is 40 volts. So we are asked to find the energy stored. So what we are going to do is to state our parameters given. We have the capacitance of a capacitor C as 20 microfarad. Look at this, very important. When you are solving for energy stored, you cannot leave your capacitance of a capacitor in microfarad. So it means that you are going to remove this micro here, and 1 micro is equals to 10 power minus 6. Okay, so we have this is 20 times 10 raised power minus 6 farad. So this is what we are going to be using to solve for our energy. Then the next one is what? The potential difference, which is what? 40 volts. Okay, so what are we looking for? We are looking for energy. Since we have these two parameters given, we are going to use the formula energy is equals to half CV what? Square. Okay, let's put in our value. So this is half times 20 times 10 raised to power minus 6 times 40 squared. Okay, so energy is equals to, with the help of our calculator, so we have 20 exponent minus 6 times 40 square. Okay, I have 0.032. I will now divide by 2, divided by 2. So the answer is 0.016. And know that energy is measured in what? Joules, right? So this is how we can solve problem on energy stored in a capacitor. So you must pay attention to your unit. Most times, capacitor is left in microfarad. That is the standard unit of a capacitor. So if it is given in microfarad, you are expected to do what? Remove that microfarad by multiplying that value by 10 raised to the power of minus 6. If you don't do that, your answer will not be what? Correct. So let's look at another example. Use the diagram below to answer the questions. Okay, so we are given this diagram. These 3 capacitors arranged in series, and each of them has a magnitude of 6 microfarad and is connected through a 100 volt PD. Alright, we are asked to calculate first the effective capacitance. Second, the total energy stored by the capacitor. Let us first solve for effective capacitance, and they are connected in series. Okay, so we have 1 over C total is equals to 1 over C1 plus 1 over C2 plus 1 over C3. Okay, so we have 1 over C total is equals to 1 over 6 plus 1 over 6 plus 1 over 6, right? So what is the LCM of 6, 6 and 6? The LCM will be what? 6, right? 6 divided by 6 is going to give us 1. 1 times 1 is 1 plus 6 divided by 6, 1. 1 times 1, 1 plus 6 divided by 6, 1. 1 times 1, 1. So 1 over this is equals to what? 1 plus 1 is 2. 2 plus 1 is 3. So I have 3 over 6. So because I'm looking for effective capacitance, so I'm going to say cross multiply. Therefore, CT is equals to 6 over what? 3. By the time I divide it, 3 into itself, 1. 3 into 2 into 6, 2. So my T effective is 2 microfarad. Okay, 2 microfarad. That is my effective capacitance. The next one we're going to do is to solve for the energy stored. And the energy, the formula for the energy is half CV square. So I have half times my C is what? 2. Remember, you remove this to half times 10 raised to power minus 6 times 100 square. Okay, so with the help of calculator, this can divide itself 1, this can divide this 1. Okay, so we are left it 10 power minus 6 times square of 100 is 10,000. Okay, all right, by the time you multiply, I'll say exponent minus 6 times 10,000. What do I have? 0.01 joules. So this is how we can solve problem involving energy stored in a capacitor. Okay, so if you are watching this channel for the first time, give it a thumbs up and subscribe to this channel for more educative videos. I'm going to pick up an assignment and you have to solve it and drop your answer in the comment section. See you next time in my next class. Bye.